Okay, in this lecture we're going to talk about multiplying more complicated polynomials, which requires, of course, being very careful as you apply the distributive property. So we'll show you some examples. Alright, so let's look at finding each product in this case. Alright, part A. Alright, let's suppose that we have 4a minus 3, and that's a binomial, and we're subtracting, or let's say we're adding 7b, and we're taking all of that and we're going to multiply it by 4a take 3 take 7b. So the thing you want to look at is recognizing that this is a number by itself, as is this. This is the same number, and this one here's the same number as this. So if this was in terms of x and y, this could be x plus y here. If I had 4a minus 3 was an x, say, and 7b as a y, then I'd have take y, and so this, remember, would be x plus y by x take y. We already know is simply x squared take y squared. So we do that in this case. So really what we have is 4a minus 3 squared minus 7b all squared. Now what happens here is that we really need to apply the squared property for this one, which will be 4a squared minus 2 times 4a by 3, and then of course plus 3 squared minus the 49b squared. And so this becomes 16a squared. We have 8 by 3 is 24 minus 24a plus 9 minus 49b squared would be the result. Alright, let's do one that's a little bit different again. Right, let's suppose we want to do x take y to the power of 4. The thing to think about here is this could simply be written as x take y squared by x take y squared. We're going to apply the squared property again. Remember, the squared property says this is simply x squared minus 2xy plus y squared. So we know that this will be simply x squared take 2xy plus y squared by itself. Right, now we can be very careful here and say, alright, well, let's make the first term here and multiply it by all of this. Then this second term, 2xy, also by all of this one. And finally, this last term, y squared, by x squared take 2xy plus y squared. So we're being very careful here to apply the distributive property. Now we do it again. X to the 4 minus 2x cubed y plus x squared y squared minus 2x cubed y here minus 4x squared y squared squared, yes, and now minus 2xy cubed. And then the final term here will be x squared y squared minus 2xy cubed plus y to the 4. Now we look to find like terms. We don't have any x to the 4 terms, so that's by itself. Now let's have a look. We have an x cubed y, so we've got 2 of them here, 2 of them here, and that looks like all of them, so that's going to be negative 4x cubed y. We now look for x squared, so this will be one of those, and we will have this one here is negative 2xy by, so this should be a plus actually. Negative 2 by negative 2 is 4, so we're going to have one of them, and 4 of them is 5, plus one of them is 6. So it looks like we're going to have 6 of these. Very easy to make an error with your signs, so be very careful. And then we have, so that one's done. Then we have a negative 2 of these and a negative 2 of them again, so it's a negative 4 of these. And we don't have any more of the x4s, so we have that, and that would be my result. Right, let's do one more. Okay, in this case here, we let's suppose that we have p plus 4q cubed. Okay, now the thing to remember about this is that this could be written as p plus 4q by p plus 4q squared. Now, of course, we can apply our square property here. Remember when we had this squared, this came out to be x squared plus 2xy plus y squared. So let's apply that. This will become p plus 4q by the p squared plus twice the p by the 4q plus the 4q squared. And we'll close the bracket. So that'll be p plus 4q by p squared. Now we've got plus 8pq plus 16q squared. So now, of course, we can apply the p to this second term plus the 4q to this second term. Alright, so in this case we get p cubed plus 8p squared q plus 16p q squared plus, we have here 4p squared q plus 32p q squared plus 64q cubed. Okay, we collect our like terms. There's only one of those. Now any other p squared q. So we've got 8 and 4 making 12. Any of these, we've got 16 and 32 makes 48. And finally we have the 64q cubed, and that's the result that we would get. So you've got to be systematic and work your way through the distributive property to get the final result for these more complicated products of polynomials.